Okay, this is units 6B and 6C for geometry. The objective for, so target for 6B or objective is we're going to solve for the missing side of a right triangle using the Pythagorean theorem. Just some quick definitions or quick nomenclature names. Every time we see the letter C in our Pythagorean theorem, we'll be talking about the hypotenuse. So every time we see the letter C, we're talking about the hypotenuse. When we see the letter A or B, we are talking about a leg. Okay? And that's every single time we see those letters represented in the formula. So the formula, the Pythagorean theorem states that if a triangle is a right triangle, the sum of the squared legs is equal to the square of the hypotenuse. And the way that looks, you may be familiar with it. A squared plus B squared equals C squared. And I'll write that a little bit neater for you. So A squared plus B squared is going to equal C squared. So this is what our basic Pythagorean theorem is. One thing I always like to tell students is if you're somebody who doesn't feel comfortable with manipulating equations, this right here works when you're trying to find the hypotenuse. If you're missing a leg, which is going to happen, then remember the manipulated formula. So memorize the manipulated formula for finding a leg. We'll do B squared is equal to C squared minus A squared. And that's to find the missing leg. Conversely, we can also say A squared is equal to C squared minus B squared. And that's also to find the missing leg. Now, it doesn't matter which leg you name, A or B. So these two equations are technically the same thing. But again, if you're not real comfortable with manipulating equations, or you're just kind of, math is not your favorite subject, it's a lot of times easier to have things pre-memorized or memorized already, so that you don't have to try to derive them or figure them out in the midst of a test. So let's go through. Let me write this back up here just for reference. Okay. So let's look at two problems. We have the first one, we're given 5 and 12. So remember I said label. So we're going to label so we know what we're talking about. So our legs are 5 and 12. Our hypotenuse is x. So what we're going to say is, according to our formula, a squared plus b squared equals c squared. So 5 squared plus 12 squared is equal to c squared. And I do encourage you, again, if this is the first time you've seen the Pythagorean theorem, to write down the formula for every single problem you do to help you memorize it. So we'll have 5 squared is 25, 12 squared is 144, and that'll equal c squared. So 25 plus 144 is 169. Now, take note, a lot of students will stop at this point and say, well, hey, I found c. You have not found c, you found c squared. The way we find c squared is to take the square root of our answer. So the square root of 169 will be equal to c. And that just is 13. So we know our side, our missing side, is 13. We take a look at our second problem. It's number 4 on your notes. We're going to start off, what do we have? Again, labeling. We have a leg, we're missing a leg, and we have our hypotenuse. So let's use that other form of the Pythagorean theorem and say b squared equals a squared minus c squared. I'm sorry, I wrote that backwards. Wow. C squared minus a squared. So the first thing we're going to do, we'll take our hypotenuse and we'll do 16 squared. and we'll have a squared. And that is that leg, the square root of 170 squared. So let's look. 16 squared is 256. Now the interesting piece about this seems like it might be a little bit difficult right here. However, we know from before, like our previous slide in 6a, we said that if we have two things multiplied under the radical and we have the same thing under our radical, then the answer is just what's under there. So we can just say the square root of 170 squared is 170. We subtract those two, and we get 86. So we get the square root, I'm sorry, so this was b squared. So b will be the square root of 86, which may or may not simplify, but I don't want to waste your time on the video doing a basic simplification. So we'll do this one in class. We'll simplify the class if it can be simplified. I don't think it can off the top of my head, though. So let's take a look at 6c. So we're going to use the Pythagorean theorem to check if a triangle is acute, obtuse, or right. So obviously what we're going to fill in, the Pythagorean theorem can be used to check if a triangle is, this should be triangle, is acute, obtuse, or right. So we just need to write down the relationships. So we're going to say if a squared plus b squared is greater than c squared, then the triangle is acute, meaning all the angles are less than 90. If a squared plus b squared is less than c squared, then the triangle is obtuse, meaning that one of the angles in the triangle is larger than 90. And of course the last, if they are equal, then the triangle is a right triangle, meaning, meaning that it has a right angle in it. That is the sole sum of Unit 6C. So some quick examples. We'll do those in class, but you do have the notes. You just heard the bell ring, so some of you I'll see here in the next few seconds.